Hi everyone, and welcome to this JavaScript tutorial to create the 1979 Atari game Asteroids, or our version of it at least. In this first part of the tutorial we're going to create the ship and make it move around the screen and everything. So you can go ahead and download this template if you like, update the title to whatever you like, Asteroids. We're going to use HTML canvas to achieve our graphical display. So give it an ID, game canvas or similar, give it a width. Width will equal say 700. Height, you can change this to whatever you like. Height will equal 500. First of all, we need to grab that canvas. Just from experience, I know that we need to give this a JS doc, so at type, just so that it recognizes it as a canvas element. So at type curly braces HTML canvas element, close the JS doc, and move to. Then we can create the variable canv, and that will equal the document. Get element by ID, and just type in the string that we had up there, the ID came canvas. Great. Get rid of this. We need to get the context from the canvas. So the context will equal the canvas.getContext, and it's going to be of type 2D. Good. We also need to set up the game loop to achieve our animation. We can just use the inbuilt function setInterval for that. It requires a handler, so that's just the function name, update, and a timeout in milliseconds, so 1000 divided by our frame rate. So we'll set up a constant called FPS. Const FPS equals 30 frames per second, say. So that'll be, we'll just leave a note, frames per second. So that means it'll call this update function once every 1/30th of a second. So let's go ahead and create that function update. Function update. What will we do first in this? Well, we need to draw. Let's plot out what we're going to do in this tutorial. So we'll draw the background, or draw space. We will draw our ship. We will, what else? We will move the ship. Move or rotate the ship first. Doesn't really matter the order here. We'll move the ship, move the ship. Draw ship, draw space. Good. Okay, so first of all, we need to draw space. How do we do that? Well, we can just set up the fill style. Basically, we'll just paint the background in black. So fill style will equal black, and we'll draw a rectangle. So fill rectangle is to draw a filled rectangle, obviously. It requires the origin, which is just going to be 0, 0, and the width, which will be the canvas width. Canvas.width, and the height is the canvas.height. Let's just run that, make sure that it's working okay. There we go, that's the background, great. Next we want to draw a ship. Now, how are we going to represent our ship? Probably the best way is just by using we can just create a variable called ship using an object, a JavaScript object. All that is a fancy array, really. So ship will equal curly braces. Now we can put all our properties in here. So what do we need to know about our ship? We need to know the x-coordinate. So let's start it in the center of the page, center of the ship, center of the ship, center of the screen. So that'll be canvas width divided by 2. The y component will be the canvas height divided by 2. What else do we need to know? The ship size. So how about a radius? R, that represents radius. It'll be based on, how about we set up a constant here? Constant called ship size, which will equal, let's put it in pixels, say 30. Ship size, or ship height maybe, ship height in pixels. You could make this a percentage of screen width if you wanted to, or screen height, but we'll just keep it as a fixed number. So the radius will be half of that, won't it? Ship size divided by 2. We also need to know the direction of the ship, the heading as such. So we'll call that A for angle. Now if you know your trigonometry and the unit circle, 0 degrees is facing right. Facing upwards is 90 degrees, so we'll put it at 90 degrees. But all the math functions don't work in degrees, they work in radians. So we have to convert this to radians by doing divide by 180 and multiplying by math pi. Divide by 180 times pi, so don't need that. Convert to radians. Okay, so we have an angle. To draw that ship, well, we need to set up our context first, set up the colors and so on. So we'll have it as a stroke style. We'll just make it white. We will maybe set the line width. We'll set the line width. How about we put that as a percentage of the ship size? So that will be, say, ship size, say, divided by 20. Good. Now the actual ship. To draw a triangle, so this is going to be draw triangular ship. Draw a triangular ship. So to draw a triangle, we need to use the path. So we can do a begin path. Just call that function begin path. And we need to move the cursor to where we want to start. So we use the function move to. It just takes an x and y component, x and y coordinate. So the x coordinate will be the x of the ship, won't it? Well, the x of the ship represents the center of the ship, so we want to add something to that. Now what do we add? Again, some trigonometry. We just need to add the ship radius multiplied by the cosine, because cosine represents the horizontal, of the ship's angle, whatever that angle might be. Right? Similarly, the y component will be the radius times the sine, so that's the vertical of the ship's angle. We can test this out. Oh, actually we'll have to draw a line first. So that's the tip of the ship, so that's the tip, the nose, I guess, the nose of the ship. Now we'd like to move to the rear left of the ship. So remember it's a triangle, so context will do a line to. So it'll draw a line from the original point, from the to where? Well, the rear of the ship, we could use that to represent the rear of the ship, just with one minor change. Instead of, sorry, I just made a mistake here. Ship Y should be minus the ship, minus that, because negative represents upwards on the screen. All right. Now to get this, to get the rear of the ship, we would change the sign. So change the plus to a minus and the minus to a plus. So this will be the rear left of the ship. Now that's the rear center that we currently have, so we need to modify this. I just grabbed out a scrap piece of paper before and worked all this out using trigonometry. So you can either do it yourself or trust me. We need to add the sine of the ship's angle here. Right. And here we just need to subtract the cosine of the ship's angle. I'm not going to explain the maths here. I don't really want to do a maths lesson. Alright, so that should draw the rear left. Now to test this, we can just use context stroke. That means it'll draw the path. Let's have a look what that looks like. That's looking good. Do something similar, so copy and paste this. This is going to be the rear right. So we're going to draw a line to the rear right now. In order to do that, it's the same thing, except all we have to do is change the sign in here. Pretty simple. Let's have a look at that. Yep, it's drawn the rear of the triangle. And finally, we want to finish off, we want to close this. So there is an inbuilt command. I think it's called close path. There we go. And that should complete the triangle for us. Great. We need to test the angles though, don't we? So go back up to the ship's angle. Change, instead of 90, change it to say 55. So it should be facing right on an angle. Cool. How about 155? That should be facing the other direction. Looking good. And we'll go back to our original. Looks like it's working well. Great. I'm just thinking we should probably put the center of the triangle in just for our testing purposes. So we'll down here, center dot. We can do that just by setting up a context fill style, which will be, say, red, doesn't matter what color. And we'll draw a rectangle, so fill rectangle. The origin will be the center of the ship, so ship dot x -1, say we'll make it, say, 2 pixels wide. The ship.y -1, and the size will be 2 pixels by 2 pixels. Let's just see if that's there. Okay. Yep. So that's exactly how we've programmed it. The center will be exactly 1 radius from the peak and 1 radius from the bottom. But that's not really the center of a triangle. When we rotate this ship, it might not look very nice. So we could, the actual centroid of a triangle is a bit below that. It's 2/3 from its peak, I think. So we can fix that up pretty simply. So 2/3, we just need to, the nose of the ship would be 1/3 ahead. So we'll go 4 divided by 3 times that. So 4/3 times that. And this will be 4/3 times that, I think. Yeah. Remembering this is all in the radius, this is the radius of the ship, so that's why we're using 4/3 here. The rear, we just need to multiply the first component by 2/3 to get this working, I think. 2/3, yep. So this first component of each of these, just multiply it by 2/3. It'll shift it upwards, basically. Let's try it. There we go, and that's actually the centroid of so if you draw a line from this vertex to the center of that side, that's how you work out, anyway, you don't need to know the maths. That's where the center of the triangle, it'd be a much nicer experience. Good. So how do we go about rotating this ship? Well, we've got an angle. We need to update the angle when they push a button, say push the left arrow key. So we'll need to set up some what do they call them? Event handlers. Set up event handlers. So we can do that just by going document, add event listener, add event listener. It requires a type. So the type is one of these here. It's actually the one we're looking for is key down. So that means it'll detect when one of the keyboard keys are pressed. And the listener, well, that'll be the function we call. So we'll just call that key down. The same thing, really. When we push the left key, we want to rotate left. When we unpush the key, that means when we release the key, I guess, we also need to capture that event. So we can just duplicate that and use the key up. So it detects when the key has come up. And we'll make a function called key up. Right, so let's do that. Function key down. It will take an event as a parameter. So we can just use our JS doc again, just to make sure it's very clear that it's an event. At type, I think it's of keyboard, yeah, keyboard event. It is there, keyboard event. Keyboard event. Oops, we need that in braces. And then we just can, so look at that again. They just call it EV, so we can do the same thing, EV. Right, now we don't want any key to do something, do we? We don't want them to push the 6 or the question mark and something happens, unless you want to program it that way. But we just want to detect arrow keys. So to do that, we can make a switch statement. Switch. Oops, I didn't close this. There we go. Switch event.keycode. So that'll detect the key code, the actual code of the key that's pressed. The arrow keys are what we're interested in. So they start at number 37, I believe. So 37 for left, 38 for up, 39 for right. That's all we need to know, I think. So we can go case 37. I don't want to add event listener. We'll break that. And repeat this for each of the key codes that we'll be using. So we'll be using 38. We'll be using 39. And just probably write a note here. So this is the left arrow. And in brackets, what do we want it to do? We want it to rotate ship left. Okay. Similarly, we want 39, 37, 38, 39. Is it the right numbers? I think so. Rotate ship right. We'll soon work out whether it's right or not. This will be the right arrow. 38, that's the up arrow. And what will that do? That will, what's the term for shooting a thrust? Thrust the ship forward. Okay, we'll do that later. So first of all, how are we going to handle this? So we push the left arrow, something happens. How about we set the rotation of the ship? So in order to do that, we'll have to give another property. We can just call it ROT for rotation. It's currently equal to 0. We don't want any rotation. We should probably set up a rotation speed here, or a turn speed, whatever you want to call it. Constant turn speed. And we'll set it in, say, degrees per second. So I'll set it to, say, 360. And this is turn speed in degrees per second. Okay. So when the left arrow is pushed, we want to update the ship's rotation. It will equal the turn speed. Now that's in degrees, so we have to divide, to get radians, we have to divide by 180 times by math pi. And this will be, we want to get the per frame speed, don't we? So we'll have to divide by the frame rate. Otherwise it'll be rotating way too fast. Similarly, just copy and paste that, put that in the right. There we go. This will just be the negative of that, won't it? So we can set the rotation. When the right arrow is pushed, we'll just set the rotation to the negative of that. Now that won't do anything yet because we need to do something with this rotation. So down where we've marked rotate ship, all we have to do is ship.angle plus equals, should this be okay? It should be. Ship angle plus equals the ship's rotation. Ship.rotation. I think that should do it. Let's give it a go. Something's gone wrong. Plus equals the ship's rotation. Probably we can open up a console here to see the error. What does it say? Reference key up is not defined. Okay, so it wants to see all these functions written first. So function key up. It doesn't do anything yet. Although, actually, let's try. We may as well put this in now. Just copy and paste the same thing. So 37 left arrow, we want to stop rotating. So when the key is released, we want to stop rotating left. This will be stop thrust, or stop thrusting. And this will be stop rotating right. Okay, now all we have to do here is instead of setting a speed, we just set it to 0, so there will be no rotation. Right, now let's try that again. Just put that down, reload. There we go. Now, if I push the left arrow, yeah. Okay, something's not. It's rotating the correct direction, so when I push left, it's rotating. When I push right, it's rotating. That's fine, but it's not stopping. So something's going wrong here. I see, in our key up, we haven't put the event. It's a bit silly, isn't it? There we go. So the key up will detect an event now. Let's try that. So left, release the key, right, release the key. Yep, our rotation is working well, but nothing else is happening. We can't thrust at this point. So how about we work on that? Can you see the center of the triangle is more accurate? If you put it at the front of the ship, how we had it, would look a bit funny. So we've used the centroid. So thrusting, how are we going to handle that? Well, we'll have to give some more parameters, some more properties to our ship. So how about we say, we'll just put a flag in here called thrusting. So that's just a true false, a boolean. And we'll say it's not thrusting to begin with. And then we'll also have the thrust magnitude. So it can be simply, it can have its own component, the x component, which will be 0 to begin with, and the y component, which will also be 0. So we can set the thrust magnitude. This allows us to, when we thrust in one direction and we release the key, the ship will continue in that direction. Even if we rotate, it will continue in that direction. Okay, so up arrow, thrust the ship. Thrust the ship forward. So first, all we want to do in this, actually, when they push the up arrow, all it will do is set that thrusting to true. That's all it will do. Similarly, when they release the arrow, it will set the thrusting to false. Great. How about where are we going to thrust the ship? We'll fix it. We'll put the thrust here before drawing it, because we'll probably want to put a little graphical display as well. That'll be behind the ship. Not trust the ship. We want to thrust the ship. Okay. So to do that, we just need to set up a if ship thrusting. So if the ship is thrusting, we want to do something, don't we? We want to increase the thrust. So to do that, we can just go ship dot thrust. Now the x component, we want to add to it. As long as we're thrusting, we're going to add the thrust. So we'll probably need a base thrust up here. So how about the, let's call it ship thrust. We'll set it to something, say 5. We'll make this an acceleration. So this is acceleration of the ship in pixels per second A little bit of physics for you. So the ship thrust equals 5. So that means in the first second it'll go 5 pixels, in the second second it'll go 10 pixels, the third second 15 pixels, and so on. So it'll get faster and faster as long as you're holding that key. So the ship thrust will equal the ship thrust x component will equal the ship thrust, right? Multiplied by the cosine, because it's going to be the x component, the cosine of the ship's angle. Similarly, the y will just be the sine component. Let's see if that works. Oh, hang on, we haven't moved the ship yet, so it's updating the thrust component, but we have to use that thrust in order to move the ship. So what we need to do is the ship.x will plus equals the ship's thrust x. And the y component will plus equal the ship's thrust y component. So this means it'll keep moving as long as we're thrusting that way, or even if when we release the key, it should keep moving. Let's try it. I'm pushing the up key. Whoa, I know what I've done wrong. First of all, we got the wrong direction, right? So in this ship thrust, that'll be minus equals the x, no, the y component, sorry. Because it was going, the y component should be minus equals. And we haven't accounted for the frame rate, so just divide all this by the frame rate. Frames per second. Okay, let's try that. Pushing up. Yep, so I've pushed up. Now, I can't pull back. I don't want to. You have to turn the ship in order to thrust it backwards. So turn the ship that way. To stop going that way, I have to thrust that way. probably will want some sort of frictional component. I know, depending where you are in space, there's not much friction, but for this game, I think we should have some friction. Otherwise, you'll forever zoom that way and never slow down. So to do that, what do we need to do? Let's add a friction constant. Constant friction. Friction. Now, usually friction coefficients in physics or whatever are valued between 0 and 1. So we'll set it up to, say, be 0.7. And we'll define that as friction coefficient of space, where 0 equals no friction, 1 equals lots of friction. Technically you can have a friction coefficient above 1, but we'll just stick to this. So 0.7. Now how do we apply that? So somewhere in our thrust, thrust the ship, somewhere in here we need to apply the friction. No, so when it's thrusting, we want it to go forward. Otherwise, so that means they're not pushing the thrust key, they're not pushing upwards. When it's not thrusting, the friction will take hold. So to do that, we can just ship.thrust x. Now we just want to reduce this by a factor of itself. So we can just do friction times, remember it's a value between 0 and 1, so it'll get smaller, times the ship's thrust, so by itself, the x component of the thrust. And we need to divide that by the frame rate. Right, do the same thing for the y component, except change that to a y. I think that should do it. So it should apply this frictional component every frame and slowly slow down the ship. Let's try it. So I'll push forward a little bit, let go, and it's slowing down. Go that way, let go. Yeah, that seems about right. So I can turn around. I'm holding the arrow key while I'm turning here. Then I'll release it when I'm going on an angle, say, and it's slowing down. Great. The friction is working well. Now in the actual game, I think you can fly off the screen. So if I fly off the top of the screen, I'll pop back onto the bottom. So how are we going to do that? So we can handle the edge of the screen just after its movement. Handle edge of screen. So we need to detect when that happens first. So if the ship's x component, if the ship x is less than 0 minus the ship's radius, either way, we want to set the ship's x to where? We want to set it to the right of screen, don't we? So it'll be the canvas width plus the ship's radius. Right. Else, if the ship's x is greater than, basically greater than this here, so it's greater than the width of the screen plus the radius of the ship, we want to set it to this part, 0 minus the radius. Right, that's for the x component. For the y component, just need to change all of this to y, 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 and use height instead. Height instead. Let's give it a go. So thrusting upwards, turning a little bit. Yep, pop back onto the screen there. Will it go this way? Yes. Going back the reverse direction. Zooming that way. Yep. Well, I'm going a bit fast. Slow down a bit. Seems to be working well. Great. Okay, that's our... I was just thinking, when we're thrusting the ship, maybe we want to add a bit of a graphic, like a bit of a thruster, like a bit of flame or something. So to do that, where we're thrusting the ship, we'll just need to draw something here. So draw the thruster. Right, so the thruster will be a triangle. So we'll just copy and paste this one. Just get that indentation. There we go. What stroke style are we going to have? Well, I'm thinking yellow. And we'll probably have a fill style as well. I've got a comma there, that's not right. Let's change that. It's amazing it's working okay though. We'll have a fill style as well, so that'll be the interior, the flame as such. Fill style will equal red. You can customize these colors how you like. The line width, probably a bit thicker, so we'll make it 1/10, so the ship size divided by 10. Begin path. The nose of the ship, it's not we want to thrust behind the ship, so to do that we need to change this to a negative, change this to a positive. Now that'll be the center of the ship. Actually, I'll copy and paste this second pass. We'll start at the rear left first, so we'll start at the rear left, paste that in there. So move to, so this will be the rear left. We want a line to the rear center, which is behind the ship. So this will be behind the ship. Behind the ship. Okay, so that's all correct, except that we want to do it behind. So to do it behind, we just need to multiply, we'll times that by 2. We'll make it 4/3. We don't need this here because it's the center, so we need to get rid of that. So lots of confusing maths, I know. So it'll just be the cos and the sine, and 4/3 of it to be behind the ship. So maybe times 2, we'll make it 8/3. There you go. That'll be twice as the length of the ship behind it. So near center behind the ship, rear center behind the ship. Now the rear left, that's correct, except that we want, we'll see what that looks like first. Now we need to also draw the fill here, so the context fill. Let's try it. Now when I thrust, whoa, it's huge, isn't it? Maybe it's a bit too huge. Let's bring the triangle in a little bit. So to do that, we can, okay, first of all, it's too far behind it, so we'll change it to 6/3, say. Now to get it a bit thinner, we could just put a multiplier in here, say 0.5, multiplier in each of these, the left component, the rear left, and the rear right. So hopefully that'll bring in the, let's try. Yeah, that's looking pretty good. You can make your own sound effects. We probably will add sound effects later. That looks pretty cool. You can adjust the size of it however you wish. Maybe you could just go with 4/3 here. What will that look like? Bit too small, isn't it? Depends what you like. I'll put it back to 6/3. Sounds good. Great, that's the thruster. Is there anything else we need to do here? I think we're pretty much, hang on, reload that. I think we're done for this tutorial. You can turn off the center dot. Just need to, where is the center dot? Here we go, just stop drawing this. And we have our asteroids ship that can go around and around, thrusting along. Okay, thank you for listening. In the next part, we'll add the asteroids. Talk to you then. Bye.